So we will have this done in no time. First of all, we will, in order to work with color images, to see our first taste of color images in this notebook, we'll just read this Tanuki image that I also have in my hard drive. So I'm opening it now. Here you have, yep, this is the Tanuki, this very nice looking raccoon, I would call it. Okay, Tanuki in Japanese. So this guy is going to help us learn a little bit about color images in Python and in OpenCV very particularly. We read them just like we read the binary images before, or the grayscale images before, using the imread method in OpenCV, but we use the imread color flag in this case, so that OpenCV knows that for each matrix position it has to find 3 values, one for R, one for G, and one for B, right? Well, about that, let me quickly run this. OpenCV is a very useful image library, and it will allow us to do many things. Okay, here it is. So as I was saying, OpenCV is a very useful library that will allow us to do many things and will work really well with PyTorch when we use that for deep learning, but it's somewhat set in its own ways. So even though it does have methods for many things and it has many very commonly used image processing algorithms, some of them very complex, already built in, it also has some very weird quirks. And the first one that you encounter is that, well, you have heard about the RGB format, haven't you? Color values are stored using 3 channels, and the 3 channels are always red, green, and blue, and the order is always red, green, and blue. Well, not always. OpenCV, for some arcane reason, uses BGR values to store color pixels. So it doesn't store the red first, the green second, and the blue third, but the blue first, the green second, and the red first. Why? Well, you can ask the OpenCV guys about that. They also have decided that the best way to sort 2-dimensional coordinates is not X and Y like the alphabet and everyone else does, but Y and X. And as things go down, they grow for some reason. Okay? So OpenCV is a very useful, very practical library, but it has some weird things. And here we are encountering the first one. Pixel values are stored in BGR format, color pixel values, instead of RGB. So in order to get them in a way that other libraries such as Matplotlib can show them, we need to invert these values, these BGR to RGB, so they can be shown in, for example, Matplotlib. So here we read the Tanuki image in this img variable, and what we are doing here is inverting the BGR to RGB. Basically, what I have here is a very nice example of list slicing in several dimensions. So it's a good thing that we did lots of algorithms and data structures, and that we spoke about some advanced Python techniques and Python syntax. In this case, what we are doing is saying, okay, let me traverse all of this img list, which, remember, has dimensions 2 by 2 by 3. Okay, so it has a number of pixels in X and in Y, and then it has 3 values for each pixel, and I'm telling it first, So see the comma, first dimension, just leave it as it is. Okay, so give me all the values. And so the second one, the same thing. But when you get to the third dimension, so the 3 values in each pixel, what you have to do is that you have to traverse everything and apply a -1 increment. So as I'm not giving it the start or the end values, those are by default from the first value to the last value, but I'm doing my increments negative, so I'm seeing them back to front. So when I see RGB back to front, I get BGR, which is what I want. Okay, or in this case, to be precise, when I have a BGR set of values that opencv has read and I want to show it, when I see the BGR in reverse, I get RGB, which is what everyone, including, for example, matplotlib, is going to want to see. So IMG contains the image as read by opencv in BGR format, and IMG2, thanks to this clever slicing, contains the image in RGB format, which is the one that the library that we use to show things, opencv, matplotlib in this case, is going to like better. Okay, so here I'm making a two image plot showing first IMG, where the color is kind of weird, and then IMG2, where the color is what it should be. It's the same as I had for, again, my Tanuki image. As you can see, the leaves are green and not this weird turquoise color. And here the raccoon seems to have gone to the hairdressers or something, because the fur is kind of red, and here it has the same color. Okay, I can also show things directly with opencv, and then opencv also knows how it's storing things. Here I'm using the imshow function from opencv, which we will not be using a lot because it doesn't work very well with Jupyter notebooks, but you can use it in your code, especially if you're using .py files. Okay, and it also knows the format and it shows the image correctly. Okay, so that was a little bit technical, but basically take away message, take home message, not take away. Take away is for food. Take home message. When I want to read a color image, I just use the imread method and I change the flag, imread color. If I need to manipulate the colors or access the values of my color pixels and so on, I have to be a little bit careful. Also, if I just want to show things using matplotlib, because I don't like CV2 imshows, for example, because it fights with Jupyter notebooks. And what I have to take into account is that pixel values are not stored RGB as anyone would expect, but BGR, because of course it is. Good thing to take into account, this is not the only thing that is a little bit weird in opencv, and we will see them when we encounter, we will see some other ones when we encounter them. Still, opencv is a very, very useful library for the type of tasks that we will be using, and it's very widely used in research in companies everywhere. I recommend that you get some experience, get your hands dirty with a couple of exercises here. You have one where I recommend that you change the colors of the circles image, the gray tones of the circles image, and just invert it. Black, what was white, and white, what was black, for example. And here you have a couple of ways to do it, or you can just Google other ways to do it, which is also a good thing to try. And here, well, now that you know how the 3 channels of the images work, you can use some more clever slicing to just store the red channel and show that using matplotlib, and that makes for a very interesting exercise too. With that, we conclude the first session of our Introduction to Computer Vision and Deep Learning course, and I hope you had fun, and see you next time.